A tree falls in a storm, and it looks like the story ends there. It doesn't. The moment that trunk hits the ground, it starts turning into something else entirely. Something closer to a small, crowded city than a dead tree. One that will keep housing new residents for decades, before it's gone. For most of the history of forestry, nobody wanted a log like this around. It got cleared away on site. A fire risk, a home for pests. Just plain messy. That was standard practice across Europe and North America for almost 100 years. Then, in the 1970s, scientists looked closer. And they proved that idea completely wrong. A rotting log isn't a forest dying. It's one of the most productive, crowded places a forest has. Foresters spent a century tidying away exactly the thing, keeping their forests alive. So what's actually happening inside that log while it just sits there? It comes down to chemistry. Wood is built from tough fiber compounds, plus one substance that acts like glue. That glue is called lignin, and it's one of the hardest natural materials on Earth to digest. Almost nothing alive can break it down. Plants evolved lignin roughly 400 million years ago. And back then, nothing on the planet had the tools to break it down. All that undigested wood piled up for millions of years. A good part of today's coal deposits came from exactly that pileup. Fungi are the ones who finally cracked it. They release a set of powerful chemicals straight into the wood. Those chemicals dissolve the wood from the outside, and the fungus soaks up whatever comes loose. That one ability is why fungi run the whole show in a rotting log. Out of everything living in that log, fungi are the only ones built for this. Everything else that happens in there only happens because fungi opened the door first. One quick correction. That mushroom isn't the fungus. It's just the one part of the fungus that bothered to come outside. That mushroom you've stepped past your whole life just turned out to be the tip of something bigger. And the strangest thing living inside this log hasn't even shown up yet. If this one's earning it so far, hit like, subscribe, and there'll be another hidden world waiting. Different fungi leave different fingerprints on the wood. One type breaks everything down together and bleaches the wood pale and soft. Another leaves the glue behind. The wood turns dark, brittle, cracked into little cubes. A third type just tunnels through wood that's already soaked in water. Beetles are usually the first animals to show up. A few beetle species can even sense a freshly fallen tree from kilometers away. That's a strange kind of housing alert system. The tunnels they drill do double duty. They let oxygen in, and they carry fungal spores deeper into the log. As the wood keeps softening, bigger insect larvae move in behind them. Termites, ants, centipedes, all follow soon after. Each group is actively helping the one that follows. The beetles open doors that let fungi go deeper. The fungi soften the wood in ways that help the next insects move in. 1 gram of this log holds more life in it than you can count. In some old European forests, a third of all forest insects and fungi live only in decaying wood. Nowhere else on Earth will work for them. A single gram of rotting wood can hold millions of bacteria, plus kilometers of fungal threads, each one thinner than a hair. That's more individual organisms than most countries have people. The mushroom you see above ground is just the tip of that web. These webs can even connect the log to the roots of living trees nearby, moving nutrients back and forth between something dying and something alive. Wood barely has any nitrogen in it to begin with, yet somehow it supports an enormous amount of life. The answer is bacteria living in the log's outer layers. They pull nitrogen straight out of the air. By the time the log is gone, the soil can be richer in nitrogen than before. Richer than it was when the living tree was still standing. Salamanders depend on logs like this one. They need steady moisture, cool temperature. Prey the open forest floor can't reliably give them. By eating leaf litter bugs, they may even speed up how fast the forest floor breaks down. Small mammals and reptiles shelter inside the log's hollow spots. Frogs tuck underneath it during dry spells just to stay damp. Eventually, once a log has rotted far enough, it becomes something new. A raised, damp bed where tree seedlings can take root. Scientists call it a nurse log. In parts of the Pacific Northwest, they've found young trees growing in a perfectly straight line. A line that traces back to a single log that fully rotted away years ago. A straight row of trees is basically a photograph of a log that isn't there anymore. There's one resident in this log stranger than anything else in it. Deep inside a wet, rotted log, there are pockets with no oxygen at all. Something else is going on in there. Microbes can live there that actually produce methane gas. A log that looks completely dead is quietly acting like a tiny gas source. Some of the fungi in there do something else entirely. They hunt. One kind grows sticky loops in its own threads that trap microscopic worms. The same trick a Venus flytrap uses on insects. Scientists have even recorded the sound of beetle larvae chewing inside the wood. A whole layer of activity going on in there that no human ear could ever pick up. Climate scientists still don't agree on one thing about a rotting log like this: whether it's good or bad for the climate. One camp says that as microbes digest the wood, they release a lot of carbon dioxide. In the short term, that makes a rotting log a source of greenhouse gas. The other camp points out that a real chunk of that carbon doesn't just float away. It gets locked into the soil for centuries, and it helps the soil hold water. Both sides have real evidence behind them. The honest answer depends on the climate, the wood, and how far the rot has gone. This one is genuinely still unsettled, which is a very calm way to have a genuinely unresolved argument. That century of clearing fallen wood for tidiness is over in a lot of places now. Many forestry operations in Europe and North America now leave a set amount of dead wood on purpose. In every area they manage, standing dead trees and fallen logs are left where they are. Some managers even kill a few extra trees themselves, just to create more of this habitat. 100 years ago, that would have sounded insane. A long list of species are now protected specifically because they can only survive in decaying wood. Their entire survival depends on a resource humans spent a century throwing away. The same wood-dissolving chemicals, fungi, used inside a rotting log are now used by people too. In bleaching paper, in making biofuel, in cleaning up pollution. We borrowed the forest's own decomposition chemistry. So the next time you step over a log like this one, look again. What you're looking at is a city mid-shift change, one you'll never see finish. Somewhere under the moss, a tree that already fell is quietly deciding what grows here next. See you in the next one.